Initiation starts the chain. Propagation continues the chain. Termination stops the chain. Have you ever looked at a free radical mechanism and wondered why some steps are called initiation, some are called propagation, and some are called termination? The good news is that these names are actually describing the job that each step performs in the reaction. If you understand what the radicals are doing, you can quickly identify which category a step belongs to. Let's start with the big picture. Free radical reactions are chain reactions. That means one radical can create another radical, which creates another radical, which creates another radical. The reaction continues like a chain. Because of this, free radical mechanisms are divided into three stages: initiation, propagation, termination. Let's start with initiation. Initiation is the step that creates the very first radicals. Before initiation occurs, there are no radicals present. Since radicals are needed for the reaction to begin, we must first generate them. The most common way to do this is with light or heat. For example, in chlorination, chlorine absorbs energy and the chlorine-chlorine bond breaks. One electron goes to each chlorine atom. This produces two chlorine radicals. Notice what happened. We started with 0 radicals, we ended with 2 radicals. That means radicals were created. Whenever a step creates radicals from neutral molecules that were not radicals before, that step is called initiation. A simple way to remember this is, initiation starts the reaction. Neutral creates 2 radicals. Now let's move on to propagation. Propagation is the chain reaction itself. In a propagation step, a radical reacts and produces another radical. Notice the pattern. We start with a radical, we end with a radical. The radical is passed from one species to another. The chain continues. Let's look at the first propagation step in chlorination. A chlorine radical removes a hydrogen atom from methane. The products are hydrochloric acid and a methyl radical. Notice what happened. We started with a chlorine radical, we ended with a methyl radical, one radical was consumed, another radical was created. The chain continues. Now let's look at the second propagation step. The methyl radical reacts with chlorine gas. This forms chloromethane and another chlorine radical. Again, notice the pattern. We started with a radical, we ended with a radical, the chain continues. This is the hallmark of propagation. One radical goes in, one radical comes out. A useful shortcut for exams is this. If you see a radical on both sides of the reaction, it is probably a propagation step. Neutral plus radical creates neutral plus radical. Now let's discuss termination. Termination is the step that stops the chain reaction. In a termination step, radicals combine together. The result is a stable molecule with no radicals remaining. Let's look at some examples. A chlorine radical combines with another chlorine radical. This forms Cl2. A methyl radical combines with a chlorine radical. This forms chloromethane. A methyl radical combines with another methyl radical. This forms ethane. Notice what all these examples have in common. We start with radicals. We end with no radicals. The radicals disappear. The chain stops. That is why these are called termination steps. A simple way to remember this is, termination destroys radicals. 2 radicals create a neutral molecule. Now let's compare all 3 stages side by side. Initiation. No radicals become radicals. 0 radicals become 2 radicals. The reaction starts. Propagation. A radical becomes another radical. 1 radical becomes 1 radical. The chain continues. Termination. Radicals disappear. 2 radicals become 0 radicals. The reaction stops. Here's a quick way to identify them on an exam. Ask yourself these questions. Did this step create the first radicals? If yes, it is initiation. Did a radical react and produce another radical? If yes, it is propagation. Did radicals combine and disappear? If yes, it is termination. Let's do a few quick practice examples. Chlorine gas reacts under ultraviolet light to form 2 chlorine radicals. This is initiation because radicals are being created. A chlorine radical removes a hydrogen atom from propane to form hydrochloric acid and a propyl radical. This is propagation because one radical becomes another radical. A propyl radical reacts with chlorine gas to form chloropropane and a chlorine radical. This is propagation because one radical becomes another radical. A chlorine radical combines with a propyl radical. This is termination because radicals disappear. 2 propyl radicals combine together. This is also termination because radicals disappear. Now let's discuss common mistakes. Mistake number 1. Thinking that every step involving radicals is propagation. Not true. Some radical steps create radicals, which is initiation. Some destroy radicals, which is termination. Mistake number 2. Memorizing examples instead of understanding the pattern. Focus on what happens to the radicals. That will always tell you the answer. Mistake number 3. Forgetting that propagation keeps the chain reaction alive. Without propagation, the reaction would stop almost immediately after initiation. Mistake number 4. Thinking termination is required to happen often. Termination steps actually occur much less frequently than propagation steps. If termination happened constantly, the reaction would stop very quickly. So if you remember one thing from this video, remember this. Initiation creates radicals. Propagation transfers radicals. Termination destroys radicals. If you can identify what happens to the radicals, you can identify the stage of the mechanism every single time.